Hello everyone, and welcome back to my channel. This is Vishnu Manjupudi, and I'm glad that you are all here. Today, we will be solving two LeetCode problems. The first one we're going to be solving is number 69, square root of x. It's just asking you to implement int square root in x. So you want to compute and return the square root of x, where x is guaranteed to be a non-negative integer. Since the return type is an integer, the decimal digits are truncated and only the integer part of the result is returned. So example 1, the input is 4, the output is just the square root of 4, which is 2. Example 2, input is 8, and the output is 2, since the square root of 8 is 2, and since the decimal part is truncated, 2 is returned. Now, this is a very trivial problem because Java already has the math.squareroot function, which returns a double. That is the square root. So all we have to do to convert, so we first have a double square root equals math.squareroot x. And now, the thing with doubles is that you can actually cast them into integers. So usually, like if you try to return Sqrt right now, you will get an error. It will say, double cannot be converted to int. This is because there might be a possible lossy conversion from doubles to ints. So instead, what you have to do is you have to cast this double as an int. The way you do that is you just put int in parentheses right before this. So now we've changed square root into an int using the casting function. And if we return this, it works. Accepted output, since when you cast it into an int, it automatically truncates this part. So like for example here, this part would be removed. As evidence if we test 8. You can see that works. So we're confident in our code, so we just submit. And our runtime was 1 millisecond, faster than 100% of Java Online submissions for square root of x. And our memory usage was 36.2 megabytes, less than 5.00% of Java Online submissions for square root of x. So now that we've completed this problem, we can just go back to the LeetCode problems and look at our next problem that we have to do. And that problem is problem 70, climbing stairs. So, problem 70, climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time, you can climb either 1 or 2 steps. And how many distinct ways can you climb to the top? Given n, you're given that n will be a positive integer. So, example 1, input 2, output 2. The explanation is that there are 2 ways to climb to the top. You can either take 2 steps of length 1 or 1 step of length 2. And then example 2, input 3, output 3. There are 3 ways to climb up to the top. 1, 1 step plus 1 step plus 1 step. 2, 1 step plus 2 steps. And 3, 2 steps plus 1 step. So the way we're going to be solving this is using recursion. So you know that from any point on the staircase, so let's say point 5, you can reach point 5 either from point 3 or point 2. So the recursion should be in point 3 or point 4. So the recursion should be climb stairs n equals climb stairs n minus 1 plus climb stairs n minus 2. So we can just calculate the first few values. So if n equals 1, we know that if you only go a distance of 1, there's one way to do that. Just take 1 step of 1, so return 1. And then we do if n equals 2. Now for 2, we already know that the output is 2. And now, since we've established our base cases, we can just return a climb stair n minus 1 plus climb stairs n minus 2. And now we should be done with our recursion. Let's run our code. Accepted for 2, it returns 2. But now let's try some recursion cases like 14. And we get what's expected. So now we are confident in our submission. And time limit exceeded when it's 45. So because this time limit was exceeded, we have to create an explicit formula to find these recursions. So let's see. So now we look at the sequence, okay? We're noticing that if n equals 0, there's one way to do it. You just don't do anything. If n equals 1, there's also one way of doing it. If n equals 2, there's 2 ways to do it. And if n is greater than 2, then it's the sum of the previous 2 terms. There's a famous sequence that follows this exact same problem, the pattern, the Fibonacci sequence. And it turns out that there's actually a closed form for finding the Fibonacci numbers. It goes like this: 1 plus the quantity 1 plus square root of 5 over 2 to the nth power minus the quantity 1 minus square root of 5 to the squared and over 2 to the n power divided by root 5. So we can just create a variable in golden ratio equals, and double, not int, equals 1 plus math dot square root pi over 2.0 2. Okay, so now we know double ants equals math dot pow. Then we have golden ratio comma n minus, and if we go here, we have minus this. The second variable is 1 minus the golden ratio. So we just do math.pow 1 minus golden ratio comma n. And then we have all of this divided by square root 5. Math.square root 5. Okay, so now that we can just return, and now we cast our and into an int, like we did on the previous problem. Ants. Except if we do this, it'll say lossy conversion, so we have to put int ants int equals int ants return ants int. Okay, now let's see how that does for 45. Incompatible types. Ooh. Well, yeah, so that was a small problem. It turns out that apparently it doesn't work for large doubles. So instead we can just use math.round. And if we run code, possibly lossy conversion. So again, we have to do int wrong answer. So it turns out that the way we implemented doubles wasn't really correct. in the sense that we have to predefine all the doubles because otherwise it converts some of them into different types. So now this should hopefully work. Yeah, one more small thing is for climb stairs, we actually have to add one to n because it's actually one behind the usual sequence, because the usual sequence has first term 0 and second term 1, but this one has first term 0th term 1. So now if we run it on something like 45, it works. So now if we submit, it works. Runtime 0 milliseconds, faster than 100% of submissions. And memory usage 36.3 megabytes, less than 5.26% of submissions. So that's all for today's episode. Thank you so much for watching. Please don't forget to like, share, and subscribe. As always, if you have any questions, comments, concerns, or any other thoughts, please post them in the comments down below. It would be really appreciated, and we will definitely read them. Once again, thank you all so much for watching. This is Vishnu Manjibhuti signing out. Bye, everyone.